So 9.5 has an interesting title. It's called Common, this word here is Logarithms. We're going to talk about common logarithms. If you remember a couple lessons ago, there was a problem we talked about when we did exponential decay, in which we had a current value of a car. It was like 9,000 something. I forget exactly what it was. And we had this equation where we said, okay, the current value is $9,000. The old value was like 14,000 something. And it was depreciating, I think it was like, say, 15% or 20%. We put 0.8 here with the t, something like that. And the question was, like, some people looked at this and said, how do you solve this for the exponent t? Well, at that point in time, we just put it into the calculator and brought up a table. We put this part into the y equals, and we brought up a table, and we saw that it took 3 years, t equals 3, to get that value. So if this happened to actually come out to be like a decimal or some other non-whole number, then it would be a little harder to figure out. But this little thing called logarithms is going to help us solve equations like this for t. But first we have to figure out what they are and how they work. So the question is, how are exponential equations like this thing here and logarithmic equations related? That word is logarithmic. So this is going to lead us into how do you solve this for t eventually. So before we even get to that, let's just talk about kind of where this comes from. What we're first going to do is just try some in our head. So it says solve for x either in your head or you can guess and check. So if we look at this, we're trying to figure out, 2 to what power gives you 32? And if you had a calculator, you could go ahead and put different numbers in, right? You could just guess and check. You could say, 2 to the third power, 2 to the fourth power, or you could just try to figure it out on your own, or you could look at the table that we had a long time ago, the exponent table, and we would find out that the number here has to be 5. So 2 to the fifth is 32. 6 to what power gives you 216? Now we're just looking at this and figuring out in our head, or to use a calculator and guess and check it. And so that would be 6 to the third power. So x has to be 3. 5 to what power gives you 0? Well, a lot of people originally say 0, but we know that 5 to the 0 gives you 1, actually. So this actually cannot happen. 5 to any power cannot give you 0, so this is not possible. Throw a tricky one in there. The next one, 7 to what power gives you 7? Again, probably just in your head, you could think, okay, that exponent has to be the number 1. Now we get to some little bit more difficult ones. What do we have? 9 to the what power gives you 1 over 81? Well, if you remember, to change this number from a whole number to a fraction, where we do this and flip it around, we want that to be a negative number. And then to get 81, that would have to be 9 squared. So if we had this as an x value of negative 2, that would make this 9 to the negative 2. It's a negative 2. You have to flip that over, make it 9 squared, and that's how you get 1 over 81. So that's it. That's the answer. For f, doing the same thing, we need a negative value. So it's x equals something with a negative. And to get 27, that would be 3 to the third power. All right, and then this next one here, we have a pretty big number. 4 to what power gives you 4,096? And that is x equals 6. Again, you could just use your phone calculator, or if you have your table, you could use that as well. So that's 6. And then the last one here, 1/3 to the what power gives you 9. So now we're going from a fraction to a whole number. That would also mean we'd have to make this flip around to like this. So we'd have to make a negative number here. And 3 to what power gives you 9? That would be 2. So this should be negative 2. Hoping that you could figure out most of these on your own. But obviously there's a way to figure this out without having to just guess or to put it into a calculator. There is a methodical way to solve these, and that's called logarithms. So how do we solve them without guessing? Logarithms. And the calculator will do it for you to figure out what it is, especially if you get to decimals and you can't quite figure out what it would be. So what is a logarithm, and how are we going to write this out? I'm not going to really get into the formal definition of what it means. There is a video that goes along with this for you to watch along with answering a mini quiz question that explains it a little bit more in depth. I want to kind of get through the math notation of how you write it and how you say it. So let's just go back to one of these examples, right? We have some number to the x power equals another number. So I'm going to use that and just put letters in with it. So we're going to say b to some exponent x equals a. Suppose we have this. Then we say x is the logarithm base b of a. And the way you write that is logarithm, L-O-G, they shorten it. That stands for logarithm. Base b, which is a little bit like it's called a subscript. It's like a tiny letter that's kind of below the g. It's not on the same level. And then this last part says of a. That is on the same level as a log equals x. So let me go through how you would say this from left to right. This would be log base b of a. Log base b of a. It says it up here too. Log base b of a equals x. So you need to practice writing this correctly, that this is a small number here, and this will be a bigger number on the same level as log. So these two things actually are the same. They're equivalent. B to the x equals a is the same thing as saying log base b of a equals x. And this is one way to solve them, because if you notice, the x here, after changing it to this form here, is now all by itself, and we get x equals the number. In the calculator, at least at school, now I got new calculators for this year, so it might be a little different, but remember last year for our old calculators, we had the words, the buttons you'd press would be math, alpha, math. I'm not sure if this is the same thing for this year. I'm going to have to double check that, but since I don't have a calculator with me, I can't check it. So that is the fill in the blank, and it might be different when we're at school. I'm going to check it on here using another website I found. This is called, it was a TI-84 online calculator, which is what you use in school. And it actually has a button on here that has a log with a little blank on here. So I'm going to use that while we do the lesson today. We're just going to practice going between these two forms, going from one thing to the other, and see if they make sense. Okay, so example 2, rewrite the following equations using logarithms, and then I'll check it with that calculator that I have on here. So we have 2 to the third equals 8. This is a true statement. 2 times 2 times 2 is 8. So I'm going to show you how it works if we use logs. So how would we do this? If you look back here, we're going from this form to this form, from left to right. So look at it. We're going to write the word log and just kind of write the base b here, comes next. And then we kind of go around to the other side and use a, and then write our equal sign and come back to the letter x. So let me show you. We're going to do log base b, so this is your b value, 2. It's a little 2 on the bottom. Go around of 8. That's on the same level. Equals, go back to the number 3. And that's how you write it. Well, let's see if that's correct. We'll put it into the calculator. I'm going to put this side in, and you'll see that it equals 3 on the calculator. So log base 2 of 8. So click on this and give you some question marks to fill in. The base was 2, and then this was 8, right? Then you just hit this little button here, and it says log base 2 of 8 is 3. And so that was the answer that we got. All right, so for the next one, practicing going around. It kind of makes a circle, remember? So you write the word log. This is your base, so base of 4. It's a little tiny one. Go around. 16 of 16 equals 2. It's that simple. The last one. Oh, by the way, 4 squared is 16. So we're just practicing rewriting these. These are all true statements. 5 to the negative third equals 1 over 125. That is correct as well. True statement. So log, our base is 5 of this number. So it's 1 over 125 equals, back around, negative 3. I'm not sure if I can put the fraction in there on the calculator, but we'll see. I'm going to do this one at least, log base 4 of 16. So let's do that one. So log base 4 of 16. Enter it. Click on this little thing to send it. Logarithm base 4 of 16 is 2. I don't know if I can do this. I'm going to try. What was the other one? Base 5 over 1 over. Okay, got that. 5. And then 1 over 125. So let's see how that works. 1 over. That might actually work. And we should get -3. So there it is, -3. So that's just rewriting it from one form to the other. Okay, so now we'll actually do it where we don't know the answer. We're going to rewrite them going the other way. We're going to write the following logarithms using exponents and then solve it. So let's go the other direction. So now we're going to start here and go to the left. So we're going to get rid of the log word. We're going to start with the base b, go over to the other side, right? It's going to be b to the a, or b to the x going to the other side equals a. So going back around. Okay, so let's try that. So b to the a, so we're going to go 10 to the x equals 100. 10 to the x equals 100. Oh, so we're just practicing rewriting this. I mean, obviously you could type this into the calculator and get the value for x, or we can look at this and say, what is it? We can solve this. So what would we put here to make it 100? That would be 10 squared, right? 10 times 10 is 100. That's how you do it. And if I were to put that into the calculator that we have, base 10 of 100, we would have log base 10, and then I'll type this in here as 100, enter, and that should give us our 2. All right, part B, we're going to do the same thing. Get rid of the log. It's going to be 2 to the what power gives you 16. So think about what that would be. That should be 2 to the 4th power. And you can check that with the calculator. I'm going to do these last two at the same time. And then the last one, cross off log, we're going to do 3 to the x equals 81. And that value should be 4 as well. So we're going to do log base 2 of 16. Try that one out. Log base 2 of 16. That is 4. And then the other one was what? Base 3 of 81. There we go. And so that would be 4. So they're both 4. And so we checked it with the answer of the calculator. So that's how you kind of go back and forth between the two. So what we're actually doing is we're changing from, the first thing we did was we changed from exponential form, because it has exponents in it, to logarithmic form. And then we went the other way. We went from logarithmic form to exponential form to figure out our answer. Okay, so now we're going to do some that are not going to be nice whole numbers. And so we have to use the power of logarithms to actually get it right. So example 4 says, solve the following exponential equations by rewriting the equations using logarithms, and then we'll solve it in the calculator. So if you look at this first one, 3 to the x equals 45. Now, all we have is that 3 squared is 9, 3 to the third is 27, and if we go to the fourth, we get to 81. So we're not going to be able to get 45 because it's somewhere in between 27 and 81. So we just probably know it's 3 point something, but we don't know the exact answer. The logarithms will help us get the exact answer. So first, let's write with logs. This would be log base, here's your base 3 of, go make the circle, of 45 equals x. So now it's by itself, and we have to use the calculator. So let's see, this will probably give us the decimal, I assume. Log base 3 of 45. It will also probably write in a different form too. So here's different form. Here's the decimal, 3.46. So we'll use that. So x is equal to 3.46. There we go. All right, we have 2 more. We're going to do log base, here's the base, 5 of 100 equals x. Type that into the calculator. Base 5 of 100. And that would be 2.86. That's the x value. So 5 to the 2.86 equals 100. Because we know actually 5 to the third is 125. So to get 100, it's going to be a little less than 3. And the last one, we would do log base 10 of 1004. Wow, that didn't come out well. Let's back up just a little bit. 1004 equals x. And let's see what that is to finish up. 1004. Oh, wait, it was 10. 10, right? Yeah. And that gives us 3.0017. So it is pretty close to 1,000, or 1,004 is pretty close to 1,000. So we'll do 0.0017. I'll go that far out. Because we know it's not exactly 3.0, so I'll go out to a couple decimal places there. So note, this is pretty important to know. What we're doing, we're changing from exponential form, because it has exponents, to logarithmic form. That's what we're doing in order to solve these problems. And they just so happen to be inverses of each other. So whenever we solve problems to undo each other, just like multiplication undoes division or addition and subtraction kind of go together, so does exponential form and logarithmic form. They kind of go together, and they're used to like undo each other. So you have a couple huddle problems to try. These ones are true and false after you write it from log to exponents. And then this one here, you're rewriting it to logs, and you have to use a calculator for it. And we're going to go for one more thing, and I think that's it. Yeah, I believe so. The last thing here is like kind of like a little bit more of a shortcut, which is in the calculator, and it's also in your cell phone. In the cell phone, it's hard to do the bases, but there are some cell phones I think may have it, but most of them don't. We'll have to do something different. In your cell phone and in calculators, they have this here. Since our number system is in base 10, right? We go like tens, hundreds, thousands, like all the places, our decimal places. We say if we have log base 10 of some number, so anytime the base is 10, we actually can just write that without having any base at all and just say log b. So these two things mean the same thing. If you see a base 10, you don't have to write any base at all. It's known to be 10. So if no number is written in the base, then assume that's base 10. So for example, solve the following logarithms. Log of 10 is the same thing as saying log base 10 of 10. So I'm going to solve that by putting it into the calculator. Now this calculator as well has just the button log. It's so common that log base 10 of 10. So if I just put in log 10, which is the original problem, log 10, we'll get an answer, which happens to be 1. But if I do the long way and change it, log base 10 of 10, which you should recognize this means 10 to what power gives you 10, it is also 1. So in both cases, it's 1. There's a button on the calculator and on your cell phone that has just the button log without the subscript, like the base with it, and this will work for that. So log of 0.1, I'm not going to rewrite it again. I'm just going to just type it in, log of 0.1. That would be -1. And the last one, log of 45. So that's saying 10 to what power gives you 45? So that would be somewhere between 1 and 2. So log of 45, 1.65. And so that's a little easier version of how to do it. If you just see the word log, it means it's base 10. Just have to memorize that. Last thing I want to go over with you is I think part of the huddle is solving for these problems here. If you're trying to solve for x and there's a log in it, just rewrite it in exponential form and you'll get the answer. So for example, this first one here, there's no base. but we need to write the base in here just so we know how to figure this out. Because we're going to do the circle thing where we go around and to figure this out. So what we do to change this to exponential is we cross it out. Remember to cross out the log. We're going to start with our base 10. Go across. 10 to the 1/2 equals x. And then you would have to put that into the calculator. I'm not going to do all these for you, but I'll show you a couple of like how to rewrite them. So that's 10 to the 1/2. And that would be an answer of 3.16 equals x. The only bad thing is that the x ends up being on the other side, but you could rewrite the other way if you want. Same thing here, just put a little base there, go around the circle. You'll do that for the first 4 here, and then the last 2, you're going to use the base that they give you. So for example, this last one here, or part E, you would do, cross this out, 2 to the -3 equals x. 2 to the -3 would be like flipping this around, making it 1 over 2 to the 3rd. And then 2 to the 3rd is 8, so it's 1/8. And you could check that to make sure it's right, but it should be. So log base 2 of 1/8 is equal to -3. And I'll do this one as well, just to finish up. If you're still here and watching, we're going to cross this out. Log, this would be 4 to the 2nd power. 4 to the 2nd equals x. So that would be 16. So they really aren't that bad, as long as you know how to kind of go around the circle and write it correctly. So this is going from logarithmic form to exponential form. And there's a mini quiz here. I'm going to post the video that goes along with this in Teams. And so it will say something about this is the logarithm video for 9.5. You just watch the video and then answer the question. And that will do it for 9.5, common logarithms.